All right, everyone. This is part 2 for the week 2 video. We're working on chapter 3, by the way. This will tell you which chapter we are at. We just did this example. And we go on to Boolean expressions. As I was saying, the conditions, if something, are evaluated to true or false if balance equal to 0. This is checking if some variable named balance is actually equal to 0. Another example, if payment not equal to balance. Remember, this is not. Okay, it's possible to have a block inside another block, and I'll make an example like that in a little bit. Okay, if statement is inside the function, yeah, we can use that. We're not doing that. We need to learn what is function first. Okay, so statements in inner block must be indented with respect to outer block. Okay, if else statement finally. We'll go back and improve that program that we started. So if something with two statements, unfortunately the indentation here is messed up, else other statement, but in this indentation is a must, as you will see in example. If and else must be aligned, unlike what we see here, so this has to be aligned to the leftmost, and this indentation statements should be inside the if block. You'll see as I do it in an example. Okay, so they suggest another example. We can go ahead and do that, but I'd rather return to the one that we started to develop. So basically this one decision structure is temperature less than 40. So presumably we are working with a variable temperature. Maybe we asked the user to provide it or got it from online, from some online source. And so we have a variable temperature and we're checking temperature less than 40. It can evaluate to true or less depending on the value of temperature. If temperature less than 40 is true, we print that, else we print that. Nice weather we're having. Okay, so let's actually go back to our previous program. Okay, so over here I was reminding you a few times that if my sales are less than 50,000, the program doesn't say anything. So I want to fix that. Else print no bonus for you. Okay, so let us see how it runs now. Nothing changed in case I'm putting in 56,000. Let me put 42,000. No bonus for you. So whatever input I give, as long as it is a number, a numeric input, either if or else will execute. So if this condition is true, sales is bigger than bonus threshold, print what your bonus is. Else, print no bonus for you. So else cover all other cases. A lot of students who are just starting with this, they try to fit in some other condition in here. No condition goes there. Else covers everything else, all other scenarios. If this is false, it's covered by else. As long as the program executed up to that point, that's the case. Another thing, this is one if-else statement. So this if is connected with that else. If I do another if statement, like if your sales are less than 20,000, you are fired or something like that, that would be a different if-else statement. Okay, so indented block can be very, very large. So there can be more than one line here. Many lines of code, actual code, or for that matter, over here. All right, so that is all I wanted to say about this example. Okay, now people generally don't like to think about abstract discussions. So after you did 1, 2, 3, 4 examples, you will see, maybe come back to it and think about it again in general. So just a quick rundown what's going on here. If condition, if this condition, whatever that might be, is true, these statements are executed. If this condition is false, these statements are executed. And then after if-else statement is over, all this thing is done, whether one thing is executed or the other thing is executed, then we continue with the program, with indentation continuing over here with if-else. By the way, that's how you know your if-else statement is over, when the indented block is over and the lineup is on if-else. If and else are lined up together. The editor will help you line them up, so depending on the editor, the behaviors may differ, but lineup is a must either way. Okay, I should not have exited. Okay, so strings can be compared using equal to or not equal operators. Also, they can be compared bigger and less than cases. Okay, so let me do another example. I want to check if the person knows the password. So password will be, say, hello, and user word. I will just ask the user to provide the password. Enter your password. So the user will enter the password. The password is a string, and with that string, I will check if user word equals to hello with capital H. The strings have to be matched exactly, so hello with capital H will be different from hello with small h. Okay, then print come in, else print go away. This is kind of a naive way to do passwords, but I'm trying to oops, double equality here. I'm trying to make the following point. So you can check equality of strings or inequality of strings. You could rewrite it vice versa. If user word not equal to hello, then go away, else print come in. That would do exactly the same job. I'm not gonna run this. Hopefully it's clear what it does, how it comes out. Maybe just real quick. Unexpected indent. Okay, so then I have to change all the indents over here and probably the inside. Okay, so I entered incorrect passwords and I was told to go away. Okay, so that's how you check equality of strings. Now about the inequality, that is a little bit more complicated, and I'm not going to go into ord and char. There is some functions that you can look up what they do, ord and char, if you have more experience or if you want to learn something extra. Basically, those functions, they are in charge of correspondence between letters and numbers. What does that mean? Your letters are ordered according to the alphabet, and the words are ordered like they would be in a physical dictionary. Okay, so B, letter B, will be bigger than letter A because B comes later in the dictionary and, well, in the alphabet and hence in the dictionary. And this is us evaluating the value of this Boolean. We're checking if B is greater than A. So far, I'm talking only to the small letters, not capital letters. I'll mention them a little later. Now, if I have a word like a B and a but, let us compare them and figure out what will be the true-false value of this Boolean. So, first letters are identical. The beginnings of the word are identical. The fourth letters are different. And in alphabet, O comes after E, and that's enough to conclude that this inequality will be true. And basically, in this order, these words would be in the dictionary of English words, for example. All right, and it's true. And I'll just write something like this. Sorry. How will it evaluate? Take a moment, think about it by yourself, and figure out the answer, and that will be true yet again. To give one that is false, actually no, that one will be true again. For some reason I like the ones that are true. Okay. So a note about capital letters. The alphabet of capital letters comes first, so they correspond to smaller values. In any case, we can compare the strings and words as well, and whether they are capital or not matters. Okay, I think that's enough of what we need to know. Basically, characters, like capital M, corresponds to a number 77, A corresponds to 97, and those functions ORD and char that I mentioned earlier, they are in charge of providing that correspondence, realizing that correspondence for you, in case you ever need them. So Mary compares to Mark. First letters are identical, second letters are identical, third letters are identical. Y corresponds to 121, bigger than 107, which is K. So this word is bigger than that word. All right. Finally, very good one. If, elif, else statement. So this is an exclusive if. Maybe that's a good way to describe them. So sometimes we have to check another if condition inside an if condition that is perfectly okay. But whenever possible, maybe it's a good idea to replace them with if, elif, else. Here is a little program. Determine if someone qualifies for a loan, they must meet two conditions. Must earn at least 30,000 and must be employed for at least 2 years. Check the first condition, and if it is true, check the second condition. Here is, by the way, feel free to stop the video and read this 2-3 times until you really understand what this means. That is like a standard procedure to solve even a rather short and basic story problem, let alone a long one. Read it until you understand it. That's the first thing. Or at least understand where to start. Okay. So, first of all, we're checking condition whether salary is bigger or equal to 30,000. If true, then years on the job, checking the years on the job. If bigger or equal to 2, if true, qualify for the loan. For example, if salary is bigger than or equal to 30,000 evaluates to false, then you must earn at least 30,000 per year to qualify. And another one, If it evaluates to false, now if that was true, and the second one evaluates to false, explain why not qualify. All right, let's realize that in code. Okay. So what does it do? We have to ask for salary. Take a moment, maybe stop the video and try to do it yourself. It's okay if you run into troubles. It's okay if you cannot finish it, but it's important that you practice on your own. This is not a spectator sport. Okay, so I'd say float of int, input. What is your salary? Well, how would I do that? If salary bigger or equal to 30,000, I'm just going simply in a better style. I would have to use it as a constant, give it a name, and assign a variable to this constant and then use it. Okay. If salary is bigger than 30,000, I want to check second condition. Then I'm asking for years on job. Before I can check that it's bigger or equal to 2, of course I have to ask for a value. Years on job equals to the same thing, float input. Question mark. Okay. Very well. Years on job, and now we are actually kind of asking the user on the variable. For example, I have to do before the next if condition, and so it kind of happens here before the diamond. And now the indented if, so this is a nested if else condition inside. So if years on job greater or equal to 2, then do this statement, print okay. So I'm gonna do the else for this if. So I'm still working to implement this scheme. If years on job bigger than 2, then you qualify. And if not, then explain why you don't qualify. Else print and you need at least 2 years on the job. Okay, question is, are we done with the program? If you are watching this, another good point to stop and consider my question related back to the scheme over here. Wait 3 seconds. 1, 2, 3. No, we are not done. Remember this part? The else part for our top if statement. This is a nested if statement. It is done. Now we have to go back to the top level and do else print you need at least 30,000. And again, it's a bit of a bad style to just include constants in your printing statements and in your code just in the middle of it, but just don't do it for longer programs. It's gonna hurt you. Okay, let's see if it runs as intended. We have indent problem. Yeah, this is out of place. And hence probably this is out of place. And now we're good. Okay. What is your salary? Let's try $40,000. Years on the job. 1. You need at least 2 years on the job. Okay. Let's run it again. And by the way, testing is an important part. You did not really do anything unless you tested that it works on different inputs. Let's say 20,000. Immediately, without the next question, we are rejected. And let's rerun it yet again. Salary 34,000. Sorry. And how many years on the job? Let's say 3. You qualify. All right, and that was a pretty good example. And in this example, we did an embedded if-else statement. And as you follow along, it's a good idea to understand how to do it without an embedded if-else statement. And I'm just going to return to it in a little bit and modify it. Okay, let's go back to slideshow. So in order to kind of flatten and not have if embedded if-else statement, because imagine embedding, indenting more, you might want to use if-else statement. Sorry, I'm losing my bearings here. So if, elif, and else, they all match together in indentation by indentation. And after each of them, there should be at least one statement. Otherwise, it's going to be a problem for the Python if nothing happens after elif, for example, statement. Okay, this is a general structure. If condition 1, statement. Elif condition 2, statement. And so on. And finally, else. Now, elif is a exclusive if. For example, if condition 1 was true, this statement is executed, and elifs and else are not checked. In general, if this is false, scanning over, this, for example, was true, then this statement is executed and else is ignored. If all of these statements are false, condition 1, condition 2, condition 3, then you use the else statement is executed. By the way, this is missing column. All right, so alignment used with So if elif else from the same statement, they are aligned on the same level, and the blocks of statements to execute are embedded. Okay, so this looks fairly sophisticated. Good thing you already know how it works. To determine a grade, if the score is bigger or equal to 90%, then your grade is A. Else, we have to check if your score is bigger or equal to 80. If true, your grade is B. Else, check that it's bigger than 70. If true, decide on your grade and so on. Finally, if the score is bigger than 60, you get a D. If it's less than 60, your grade is F. So we already know from our experience how it works. And imagine indenting 1, 2, 3 times. So all the text moves to the left. So I could definitely do this with an indented if-else statement, but that's probably not the best. So there is something to be said about exclusivity of this. If the score is bigger or equal to 90, I don't need to check everything else. Like if my score is 92, my grade is decided, I don't need to check if it's also bigger than 80, which of course it is, but that's irrelevant to my problem. So if elif else statement comes great there. Okay, let's do this program. I'll need to start a new file and write out the algorithm. So let me say grade, and again it is float input, enter your grade. Okay, and now our huge if elif else statement. If grade bigger or equal to 90%, let's double check with the specification. I don't remember what they are doing. Yes, bigger or equal to. Okay, print your grade is A. Where is A? Yep. And then I will do elif. I will type it up instead of just copy pasting and modifying. Maybe that way you will remember it better. Elif grade bigger or equal to 80. Then print your grade is B. And for the rest of them, I will just copy paste and modify. Notice indentation. If elif indented at the same level and each of the indented blocks to be executed is indented by how many? By 4. Okay. We can actually run and that will check for us that the indentations are right. And this is a grade problem. Okay, it works. I don't want to start it. If grade is bigger or equal to 70. By the way, once you are more experienced, you will see and know that whenever you have to copy and paste code, that is a strong hint that things can be done in a more rational way. Copy pasting code like this is really something that can be optimized. All right, so your grade is D in that case. And finally, all the other cases is else print your grade is F. Okay, so I just solved that problem and let us run. Before we run, notice that this is one statement with indented blocks of statements inside it, but this if, elif, they are together in one if, elif, else statement. Okay, run. Enter the grade 40. The grade is F. Let's rerun. Enter your grade 78. The grade is C. Seems to work, and I guess that's it for the example. Notice one thing for people who do this for the first time. Else does not come with conditions. It handles every other case that were not covered previously. Okay, sorry. We are going back here. Okay, now it's time to talk about logical operators. So if your values are evaluated to true or false, then and or are your friends. So true and true will be true. True and false will be false, for example. Anyway, those are binary operators connecting two Boolean expressions into a compound Boolean expression. This is the part that takes students a while, and that's why I think this week should be longer than 1 week. Not operator, not true is false, not false is true. So far, so good. Here is a truth value for AND operator. False and false, false and true, true and false. Look here, false and false gives false, of course, false and true gives false. And just to summarize this table, the only way how AND gives a true answer is when each of the components are true. Remember how AND works. AND will return true if each component is true. Or, this is for OR operator. I really hate that they printed AND in between. So false or false returns false. The only way how OR returns false is if each of the statements is false. In other words, it's enough for one of the Booleans to be true to have OR statement to be true. Okay, hence there is something called short circuit evaluation. Sometimes it's called cutoffs, deciding the value of compound Boolean expression after evaluating one subexpression. For OR operator, if the left operand is true, we don't have to consider the right one. One of them is true, hence the whole OR operator returns true. If the first one was false, then you have to check the second one because maybe that one is true and that will give true to the whole OR operator. AND operator, if left operand is false, then you don't need to check the right one, the whole value is false. All right. Truth table for a not, as I was saying earlier, not true is false and not false is true. Example. So what do you think this will print? By the way, parentheses over here are not needed, although sometimes I actually end up writing them to be sure this is evaluated first. So I have some x value. X is bigger or equal to 10, and x is less or equal to 20. So AND will be true when each of them is true. Hence, my number has to be between 10 and 20. For example, 15, if x equals to 15, it satisfies both conditions, and the value of this whole Boolean will be true. If x is 25, 25 is indeed bigger than 10, 25 is smaller than 20, so this is false, and AND operator will give me false. Okay, to determine whether numeric value for OR, this will let us think about numbers that it will be accepted, that will return true. If x is less than 10, for example, x equals to 5, 5 less than 10, this is true, so the whole statement is true. This doesn't have to be true. If x is 25, this is false, however, This is true, 25 is bigger than 20, so OR statement returns true. How OR statement can be false? Each of the statements have to be false. That is, if I try 15, 15 less than 10, false. 15 bigger than 20, false. So this value will be false when x equals to 15. You end up using this OR and AND a lot. Sorry, turtle. Too early for turtle. Boolean variable. So variable that takes value true or false. They are used as flags, so sometimes you change the value in your code from true to false, and then the code, for example, you want to exit a loop, some sort of exit condition. Or you want to ask a user, do you want to continue with this program if this program is doing something complicated? So I'm going to talk about the turtle later. Let us play with true and false so that you actually understand what